All right, so this is just a very improvised question here. So I'm gonna try to solve this. I mean, I watched a YouTube video. I watched thinking about the logical solution part, and I remember solving this a while back. So I somehow solved it again. So this is what I had in mind when I first started out, right? We loop through the array, and when we get to an index, right? The brute force solution. This is the brute force solution, by the way. When we get to the index of this index, we look at we first try to find what the walls is of the right side and the left side. So for this container, where are the walls? Well, the wall is the highest number from this valley. So if you look at this number, what is the highest point to the right of me? Well, the highest point to the right of me is this wall right here. Well, what is the highest point to the left of me? What is this wall right here? Well, cool. Now that we know where the walls is, now that we know how high each wall is, where's this building point? Where does this water get spilled out? Well, we take the minimum of this number and this number. So the minimum of this two number is this number. So the water is going to spill out this way. So no matter what, the water cannot be higher. The water level cannot be higher than the minimum size of the wall. So now we look at this wall, and now we take the height of the wall, and then we're going to subtract the current depth of the hole, and then from there we can get the volume of that index. So that was a strategy, and that was a pretty easy solution to code up. Something edge case. Let's say you are at this index, right? What is the height? What is the highest height to the left of me? Well, that is 3. What is highest height? Oh, I'm sorry, that's not it. This is right here. So 420325. Actually, no. Let's say I'm right here. What is the highest height to the right of me? Well, that's none of them. That is gonna be none. That's one. The array is gonna return one, right? Well, what is the highest height to the left of me? What's this one right here? That's gonna be 3. Okay, now find the minimum of both of them. Well, this is 1. Well, 1 minus 2 is -1. So that's an edge case because if we put water over here, we cannot have negative water, so it's going to spill out. So which means we have to have a conditional check to see if, well, maybe if the point we're at right now and the point to the right of me, if there's nothing to the right of me that's higher than the point in the current one, then that means the water's going to spill out. So no matter what, we can only keep the water amounts positive. So that's just an extra conditional check. So how I would solve it is this is how I solve it, by the way. So for I in range of length, and length is going to be equal to length of height. That's where we mapping through every single index of the array. And we're gonna have a total here that start off with 0, right? And we're gonna add to the total the minimum, the well, we want to find the two wall first, right? So the maximum, so we're gonna find the maximum of the left of the array. So that's gonna be height, and up to that I point. That means every item of before I. So that's gonna be 4 and 2. Let's say 0 is the number I'm looking at right now. And now the maximum of the height to the left to right of me. So that's I and beyond. So that's gonna be all of these index. What is the highest wall to the right of me? So that's gonna be the first conditional. And now that we find the wall to the left and right of me, we're gonna find the splitting point, so the minimum of the both wall. So where is the spilling point? Okay, it's gonna spill at number 2. It's gonna spill. Let's say this is the first index. This is the first scenario. We have 1 is the height of the left wall. 2 is the height of the right wall. Well, where is it gonna spell out? Well, it's gonna spell out at the left side. So the left side is 1. 1 is the minimum. So no matter how high the second wall is, the first wall is lower, and that way we can only hold as much water as the first wall. So we're gonna take that, the minimum of the both side, the minimum wall, and we're gonna subtract that from the current index, which is gonna be height at I. And then from there, we're going to return total. But the problem with this scenario is that if we get to an index like this index, which is 2, right? And we can't find and the minimum to the right of me is 1. Well, if we put water on this number 2, the water is going to spill out this way, and there's nothing holding it. But in mathematical operation, what will happen is that it's going to end up with a negative 1, because the minimum to the right of me is negative 1, but the minimum to the left of me, the maximum to the right of me is 1, and the maximum to the left of me is 2. Well, actually, no, it's 3. So we're going to take the minimum, which is the wall. Well, that's just a 1, but that 1 is lower than 2, so that's going to give us a negative 1. So we have to do another conditional check right here. So if cur, let's call this cur, right? Cur, if cur is less than 0, is more than 0, that means we are holding water, and total plus equal to cur. And that brute force solution should work. What on earth is going on? Max arg is an empty sequence. Okay, we have to start at first index. Okay, yeah, so that's the brute force solution. And now we submitted that because we can't just take, because I initially it's 0, right? So this number can't hold anything, the number to the left of it. So let's submit that. It should be very, very slow, but the test should be passing. This is an open square solution, because for every single one of the index, we are looking through all of the number to the left of us and all number to the right of us to find the lowest and minimum. Now if we print out the maximum height as we go along, right? Let's say maximum I of I. Let's say max height of I. We will notice a pattern. So this is all the max heights going to the right of us, right? So as we go from left to right, this is all the height from the max height. Okay, now what do we go from right to left? So that's gonna be I here, around here, from right to left. So that's going from this side to this side. Well, we start off with a very big number from right to left. So that's open raw here. This is where we start out, and this is what we end up with. And this is 3. So the biggest number to the right of us is 3. And if you recognize that, it's just basically the biggest number continuing. So we can probably optimize this by not doing this. We can make it an open operation by pre-computing this value and then using this value to, because we recognize the sequence, we can pre-compute the sequence and use the sequence to compute our final value instead of brute forcing it and looking at this value over and over again by do that. So to pre-compute the value, we need to have 3 dedicated arrays. So that's the first array is going to be forward equal to 0 for in range of length. The second one's going to be backward. And there are some edge case with this array, which is approach 2, which I'm going to get up, which I'm going to solve later. We have to modify this a little bit more later on. And from there, we can pre-compute the value going forward by doing for I, comma n in range, in height. So the first value is going to be 0, right? So the previous value is going to be 0. So I minus 1 is going to give me 0. So no matter what, the last element is going to be 0. So for I in n for if forward at I is equal to, with the current index, this is 0, is equal to the max of n, which is the current index, which is in height, that is going to be 0, or the previous one. So that's going to be forward at negative 1. No, I minus 1. Forward at I minus 1 is the previous index. Right now, because forward is right now is because it's 0. Um, I minus 1 is a 0, which is the lowest number we can find. So that's fine, but that's going to cause issue when we go forward, when we go backward. So right now, if we went forward, it should give us an increasing sequence of number. Okay. Enumerate height. Okay, 0, 1, 1, 1, 1, 2, 2, 2, 3, 3. Yeah. So that's gave us an ever increasing number. So now we're gonna go backward and collect those number too. So that's for I, comma n in enumerate height, but backward. Now gonna be backward at I is equal to max of height of backward of n or backward at I minus 1. This is gonna be kind of slow, but this is gonna be over anyway. So now we do that. We're gonna do backward is equal to backward. Flip it over again, and print backward. Yeah, that's not very efficient, but I'm just doing this for demonstration purposes. So that's 3, 3, 3, 3, 2, 2, 2, 2, 1, right? Okay, so now we can look at this array. If we print forward and we print backward, we print the height of the original array, we get a sequence of number that we can probably use. So now if we look at the first one, what is the maximum height to the left of me? Well, that's just 3. What are the wall to the left of me? Well, that's just 0. What is the wall to the right of me? That's 3. Well, 3, the minimum of that is 0. So 0 minus 0 is 0. Let's look at the second one. Is the second one, what is the wall to the left of me? Well, that's just 1. What is the wall to the right of me? Well, that's 3. The minimum of that is 1, so that's 0. 1 minus 1 is 0. Let's look at this one. The minimum, the wall to the right of me is 3 high. The wall to the left of me is 1 high. Well, the wall to the left of me is going to be the one we use. So this 1 minus 0 is going to be 0, which is going to give us the result. So now if we loop through, so for I comma n in enumerate height, right? One more time. Total plus equal to the minimum of forward at I, backward at I, minus height at I. Now we print out total, we should get the right answer. We got 6 here, so we're going to return total because strongly typed Python requires to do that, and that also gets case passing. I didn't realize this optimal solution until I looked at the sequence that it's printed out, and I recognized it right away. And yeah,